Welcome to another vlog edition of my YouTube channel, Data Science with Sam. This video is a continuation of the deep learning series that I started a couple of weeks back. In my previous video, I spoke about deep learning, like what is deep learning and how it differs from machine learning and how it's also revolutionized the field of artificial intelligence in last 1 decade. I spoke about there's some applicability of deep learning in different industries as such automobile, manufacturing, healthcare, and even in the entertainment industry. Now, if you want to apply deep learning for your data science work, how are you going to build a deep learning technique, right? So let's talk about the main building block of deep learning, which is nothing but neural network. The original idea of neural network was inspired by human brain. We know that from our biological class that neuron is one of the main component of human brain. And those neurons are connected by synapses and they carry out some activation function that help us to perform some biological activities in our body. So similarly, we have neurons in artificial neural network, and those neurons are responsible to carry out those computational functions that derive the prediction or any kind of classification model within that neural network. But the architecture of artificial neural network is less complicated in comparison to human brain. In artificial neural network, we dealt with 10,000 neurons, as opposed to in human brain, we have around 80 to 90 billions of neurons. So now let's see what are the main components of neural network in the next section. So the topology of neural network architecture is very simple, as it's mainly built upon 3 major components: input layer, hidden layer, and output layer. Input layer, as the name suggests, is mainly responsible to collect the input data and pass the data onto hidden layer. Hidden layer performs the main computation using the data. It also performs the feature extraction because without the main features, it will be difficult to perform the computation. Then after that, the computation results pass it on to output layer. So based on the classification exercise, whether it's a binary or multi-class, the output layer is segregated into different sections. Like if you're performing a binary classification exercise, your output layer will only have 2 classes. Let's think about a computer vision exercise where you're trying to detect an image of cat or dog in a data set, in a particular image. So in that case, you're trying to perform a binary classification. So your input layer will collect a combination of cat and dog images. It will pass those images to hidden layer. Hidden layer will collect the key features corresponds to cat and dog image and then perform classification exercise. So once that classification, the actual classification computation will get done, it passes that results to output layer. And output layer will denote that result in a form of 2 classes. And one class corresponds to cat and another class will correspond to dog. So that's how neural network usually perform classification exercise using these 3 major components. Now hidden layer has 2 different sections. It has forward propagation and backward propagation. So which usually responsible to perform the main computation combinedly. Now let's check out in the next section how these 2 propagation techniques carry out the main process within the hidden layer. In previous section, I talked about 3 important components of neural network: input layer, hidden layer, and output layer. Now let's talk about how these 3 layers correlated with forward propagation and backward propagation technique, which help the neural network to learn the data and predict accordingly. In the forward propagation stage, it's trying to make a guess of the answer, means the actual prediction happens here. So first, it randomly initializes weights W1, W2, W3. It multiplies those weights with the X1 and X2 input data to form the hidden layer, which is denotes here like H1, H2, H3. So these are the 3 hidden layer data points. Now, after that, hidden layer perform the final computation and provide the results to an activation function. So this activation function will assess the results, and based on the results, it's calculate the probability score, and the final results it's come as a probability percentage. Like suppose if you're performing cat versus dog binary classification, then activation function will be responsible to segregate the classes based on the probability score and provide the output at the layer accordingly. So now in the forward propagation section, you must be wondering that when we are calculating the weights, and we're calculating the hidden layers based on multiple random weights and input data. So what's the possibility that the randomly initialized weights are accurate and it can perform a better prediction with higher accuracy? It's not possible to determine that at the early stage. And that's why we need to perform backward propagation, where we need to find out what's the minimized error rate, because in most of the cases when you perform forward propagation in the hidden layer, the actual guessed output deviates from the actual output. Like for example, like if you're trying to calculate a certain classification exercise, it's possible that your expected probability score does not match with the observed probability score. So in that case, your neural network ends up having some errors. So backward propagation helps us to minimize that error. And how it does, it basically calculates the expected value and observed value using a loss function. And then they perform a derivative of that errors for different weight and pass it to the initial weights. So actually in the backward propagation, we continuously update the weights by calculating the derivative of the errors. So eventually it helps those weights to find out the optimal parameter, optimal value, which will minimize the loss function and the error rate. So once this backward propagation done simultaneously with forward propagation, it eventually reduces the error rate and help neural network to predict with a better expected value, observed value. So once the expected value and observed value matches, or at least it comes close to each other, then backward propagation step stops. So when backward propagation stops, then the forward propagation techniques triggers the activation function, which provide the final probability results at output layer. So that's how forward propagation and backward propagation execute simultaneously or concurrently, sometimes to perform the final computation in the neural network. So now let's move on to the next section to conclude this video. So today's video covers a very important aspect of neural network. You learn the basic components of neural network. You also understand how forward propagation and backward propagation works. So those two propagation techniques are the main driving factor of the actual computation happens within the architecture. But that's not the end of the show, because if you want to learn neural network architecture development, you also need to understand how you can manually select the hyperparameters, which can make your model less erroneous, with a better prediction rate and less time consuming. So how you can achieve that? So I'll cover that in my next video, where you'll get an idea of those hyperparameters that you need to select during model building phase. So neural network model hyperparameter selection is coming in my next video. So stay tuned for that. Also, please don't forget to like and subscribe to my channel, because more contents are forthcoming. I'll talk about neural network and some other aspects of artificial intelligence in the next few months. Also, please look down at the captions as I shared some of the learning materials that will give you a comprehensive overview of deep learning and neural network architecture. So stay tuned. Till then, goodbye.